On this problem, we are to construct a polynomial function p of x of degree 3 with real coefficients that has zeros x equals -2 and x equals 1 minus 3i. We want to multiply out the factors and combine all like terms. In other words, do not leave p in factored form. Okay, so the fact that it says real coefficients means that we can take the complex imaginary zero and know that we also have its conjugate. So 1 minus 3i, we must also have 1 plus 3i. If you don't have complex conjugate zeros, when you multiply it together, you won't have real coefficients. So it said real coefficients, that means that we get all complex conjugates as part of the package. We now have 1, 2, 3 zeros. That's perfect for creating a degree 3 polynomial. So, from factored form, if x equals -2, that implies that x plus 2 would equal 0. Similarly, if x equals 1 minus 3i, that implies that x minus 1 plus 3i would equal 0. How am I doing that? Very simply, just moving everything to the left so that it's equal to 0 on the right. So we also have, if x equals 1 plus 3i, our new 0 that we assume from our information about real coefficients, we know that x minus 1 minus 3i equals 0. Okay, so if we take these, let's see, that blue looks good, these factors that equal 0, these three objects, let me put parentheses around them, makes it easier to distinguish them as a single factor, which they were before, now it's clear. These three factors are all equal to 0. If I multiply them together, the product of 0 is 0. So 0 times 0 times 0 is 0. And this is now the polynomial that we're looking for. Specifically, this is a polynomial that very clearly has the given zeros. And so therefore, we can jump from here to the polynomial p of x, which is the product of three zeros, is the polynomial that has the zeros that were given. Oops, that's a 1 minus 3i. There we go. That's really the answer we want. However, it said don't leave it in factored form. Why? Well, it specifically says it needs real coefficients, and there's I involved in these. So we need to now multiply stuff together. Okay, the things to multiply together are the complex conjugate factors. We made sure to grab complex conjugate factors because they play nicely together when you multiply them out. They make real coefficients. So we're going to work here, multiplying all of this stuff together. So we're going to get x squared minus x minus 3ix. Next one, distribute that -1 through. That'll be minus x plus 1 plus 3i. And finally distribute the 3i through, and we get plus 3ix minus 3i minus 9i squared. Okay, now something cool happens in here. Everything that has an I in it will either add to 0, like these. Let me put a double mark there so you can see what's, or transform into a real number. So we now have, this is x plus 2. Let's just simplify. We have x squared. Notice we have minus x and minus x. That makes minus 2x. And we have plus 1. And this term over here, minus 9 times minus 1, is plus 9. So we have plus 1 and plus 9. That makes plus 10. Looking great. This now has real coefficients. However, the instructions are not quite done. It says multiply out the factors and combine all like terms. So we still have factors to multiply. All right, so we get back to distribute. This would be x cubed minus 2x squared plus 10x, and then distribute the 2 through. That would be plus 2x squared minus 4x plus 20. So let's now write our final answer. We have an x cubed. Do we have any like terms? Oh, the 2x squared and the minus 2x squared go to 0. Was not expecting that, but come on. But sometimes that stuff happens. There we go. And we have a plus 10x, a minus 4x. That's plus 6x. And plus 20. This is the polynomial that has the given 3 zeros, well 2 and the one we knew, and it's degree 3, and it has real coefficients, and it's all multiplied out, not in factored form. That completes this question. I hope this helps. By the way, there are many other techniques of multiplying these complex conjugates together that can speed things up. I could do a video where I show you how to just do it in your head. But this is a nice secure approach, and make sure the pattern that all the i's either add to 0 or the I squareds transform to real numbers when you're done.